So today we're going to start the unit about chemical foundations. We're going to talk more about elements and include atoms and ions. So today we're going to discuss just elements and compounds. Okay, so there are about 115 different elements known if you take a look at a periodic table, and that number can change as new elements are probably not discovered anymore, but created. 88 of them occur naturally, and so those are the ones that are just found. The others are usually created in a lab. We know from the previous unit that compounds are made from elements. We have to put two different elements together, two or more, to get a compound. So this is similar to like the alphabet. We have only 26 letters, so those would kind of be the elements, but then we combine those letters or elements into lots of words or compounds. So let's talk a little bit more about elements and how they relate to the periodic table. Element names, especially the 88 that are naturally derived, so the names are usually derived from Greek, Latin, or German. And usually these names describe some property of the element. So for example, bromine is the Greek word for stench because bromine is one of the only elements that exist as a liquid, and I guess it probably smells bad. Gold is the Latin word aurum, meaning shining dawn. Gold's really shiny, it looks like the sun, those kind of things. And lead is the Latin word plumbum, meaning heavy. Lead is a very heavy element. Well, it's hard to write all the names all the time. We'd be writing all the time. And so we have to come up with a way to abbreviate the name. And so that's where we get the element symbol. Usually it's the first letter or the first two letters of the element name. The first letter is always capitalized. If there is a second letter, it's always lowercase. Now, sometimes the first two letters used, or the two letters used aren't the first two letters of the element name. So, for example, zinc, instead of it being Zi, it's Zn. Chlorine, instead of it being Ch, it's Cl. And sometimes these symbols are based on the Latin or Greek name, not, the, English name or the name that we call it. So, for example, gold is Au, based on that Latin name, and lead is Pb, based on its Latin name. Okay, well, when we take elements and form compounds, we come up with what's called the law of constant composition. And that says that a given compound always has the same composition, regardless of where you get it from. So, for example, water always contains 8 grams of oxygen for every 1 gram of hydrogen, and it always has to be that ratio. Otherwise, if the ratio is different, it's not going to be water anymore, it would be some other compound. So no matter where you get water from, it's going to be this ratio, otherwise it wouldn't be called water, it's another compound. Well, after this, in 1808, Dalton, he's a scientist, he did a lot of work with atoms, and he came up with a theory, and it had 5 postulates. So first he said that elements are made of tiny particles, and we're going to call these particles atoms. And then he said that all atoms of a specific element are identical. So if you had some gold and then had gold from another location, those atoms would look identical. But they're going to be different from maybe lead or silver or some other atoms from another element. Then he also said that atoms of one element can combine with atoms of another element to form compounds. And then we also talked about the law of constant composition. So he said that a given compound always has the same relative number and types of atoms. So your water is always 2 hydrogens, 1 oxygen, things like that. His last part of his theory was that atoms are indivisible in chemical processes. So you can't create or destroy atoms in chemical reactions. You just change the way that the atoms are grouped together. And we'll talk more about that later on. Okay, so we've talked about elements and atoms and how different atoms can be combined together to create compounds. So a compound, as we discussed before, is a substance composed of atoms of 2 or more elements. And they always contain exactly the same relative masses. So that's our law of constant composition. Well, we've got to find a way to represent this compound kind of in a shortcut method using element symbols. And so that's what a chemical formula is. It expresses the types of atoms and the number of each type in each unit or molecule of a given compound. So we're expressing 2 things, the type of the atom and the quantity or the number. So to represent the atom, we're going to use the element symbol, and to represent the quantity, we're going to use a subscript. So the subscript are small numbers that are down below. If there's 1 of that particular atom, we don't write the subscript 1. It's always understood, and we don't write it. But anything more than 1, we'd write the number. So for example, H2O, we've got 2 hydrogens and 1 oxygen. And we know we have 1 oxygen because here we would put a 1, but because it's a 1, we don't write it. It's understood. Okay, so element symbols and then our subscripts. Okay, there's a few rules that you need to know in order to write formulas. Each atom present has to be represented using its element symbol. The number of each type of atom is indicated by the subscript, and we put it right after the element symbol. And like we talked about before, if we only have 1 atom of a particular type present, we don't write the subscript 1. Putting the symbol is kind of our way of saying there's 1 of them. Okay, so let's try a couple. So it says each molecule of a compound that has been implicated in the formation of acid rain contains 1 atom of sulfur and 3 atoms of oxygen. Now right now we're not going to worry about the order of the elements. I would just put them in whatever order that they're written. And so since sulfur is written first, we're going to put S because that's our symbol for sulfur. You can find all these symbols on the periodic table. Because there's 1 of them, I'm not going to put a subscript. And then I've got 3 atoms of oxygen, so I'm going to put my symbol for oxygen and put my subscript of 3 representing the 3 atoms. Okay, each molecule of a certain compound contains 2 atoms of nitrogen and 5 atoms of oxygen. So my symbol for nitrogen is a capital N, and I'm going to put a 2 after it because it indicates there are 2 atoms, and 5 atoms of oxygen, so I'm going to put an oxygen and then a 5 after that. Okay, notice I'm writing this like one word. Everything is kind of smushed together. The nitrogen and the oxygen aren't separate. And then I'm using subscripts, which are those small numbers down below, after each symbol to indicate the quantity. So it's like one word. It all goes together. All right, last one. Each molecule of glucose, a type of sugar, contains 6 atoms of carbon, 12 atoms of hydrogen, and 6 atoms of oxygen. Okay, so first is carbon. Symbol for carbon is a capital C, and there's 6 of them, so the 6 goes down there. Then we've got 12 atoms of hydrogen, so H, and then a 12. And I've got 6 atoms of oxygen, so O, and then a 6. Okay, so we'll do some practice with that. Okay, so here is your check for understanding for Section 1, Elements and Compounds. Before we get to that, here's a Chemistry Cat video that relates directly to what we're talking about today, element symbols. All right, Section 1. Okay, so number 1. How are element symbols determined? And please provide an example. So, what are the rules when you're going to write an element symbol? Number 2, make sure you restate the law of constant compositions in your own words. So try to put it in your own words so you can remember it more easily. And discuss an example that explains the law of constant composition. Number 3, summarize Dalton's atomic theory in your own words, okay, because you're going to definitely see this again. And number 4, write the compound for each of the following examples. Okay, so this is what we'll go over when we check off your notes. If you have questions, let me know. Have a good day.